So in this exercise, I want you to know how to calculate the following whilst you are using your logarithms, and do that with your calculator to check if the answers they are correct. So these are typical questions where the logarithms are to play a role, or they are to be very, very useful in calculating these typical questions. So as you are given, calculate the following and check your answers with your calculator. So you are given the product of two numbers. They want you to multiply these two numbers as we are given on number one. 19,4 multiplied to 0,462, like this. You are required to multiply this, which you could have just multiplied direct on your calculator. Okay, this is it here. As we are having our calculator, we can multiply these two numbers, 19,4 multiplied to 0,462. And we can have our answer, which is 8, depending with the degree of accuracy. If you want to round off this to 3 decimal place, just press 6 on fix, then 3 decimal place, that will be 8,963. Okay, but they do not want us to do this. We are supposed to show clearly each and every step. So you're supposed to show every step to be taken in your calculation using the laws of exponents, or use the laws of logarithms. Use the laws of logarithms. So on using the laws, it means we must have a log. And on the logarithms that you are going to introduce, this is what you're going to need. You are going to introduce a logarithm, which is a logarithm of a certain number in the base of a 10. Or you are going to introduce a ln, which simply means if I introduce a ln, let's say I'm having the ln of x, it means that is the logarithm of x in the base of e. That's a Napierian logarithm. So you are going to work this question depending with how the question is given. They just asked you to use logarithms. You can use a ln, you can use a log. They ask you to use logarithms in the base of 10, meaning to say you're supposed to use this condition. They asked you to use the logarithm in the base of e, which is the Napierian logarithm. You use exactly how you are given on that particular question. But everything that you're going to use, or that you're going to apply, you are going to use, like I said, the laws of the logarithms. And the laws of logarithms test that if there is a division of numbers under a logarithm like this, it means this was taken from the logarithm of a minus the logarithm of a b. You are dividing the numbers, it means you are subtracting the logarithms before. If you are having a product of these two numbers under a single logarithm and having the same base, it means you were adding the logarithms. That is log of a plus the log of b. The same concept if you are given log a to the exponent of n, where n is an exponent. This is going to be n, the logarithm of a. So these are the typical questions that you are going to have. All you just need is to make sure that you work out your questions properly in your simplification. So when you're given log a to the exponent of n, this is n log a. This is an exponent, and this is going to just multiply a logarithm. So these are the basic laws that I want you to focus on, work on, revise on as much as you are going to answer these questions. This is what you are going to need. So separate whatever that you're going to be given and apply your laws. All right, so this question that we have here, we are going to write it in a way that we understand. So this is what you're going to do. You are just going to introduce this. Let x be equal to these two numbers. That is 19,4 times 0,462. So if already you are given as x is equal to, there's no need for you to write let x be equal to. So this, you simply need to have something on the left-hand side and something on the right-hand side so that you can introduce your logarithms. And take note, if you are introducing the ln, it's the same thing. If there is a ln here, it means it's going to be ln A minus the ln of B. If there's a ln here, it's going to be the ln of A plus the ln of B. If there's a ln here, it's going to be n, the ln of A. So whether you're using the log, you're using the ln, are the same laws, same application. All right, so at this stage, if you are to introduce the logs in this case, all right, let's say I introduced a log which is in the base of 10. So you are going to introduce the logarithms both sides of the equation. So there you are going to introduce a log. So it's going to be the log of x, which is equal to the logarithm of what is on the right-hand side, which is 19,4 times 0,462 under a single logarithm. As long as the logarithms are being introduced, that means we are going to use this concept. We are going to apply the laws. From our laws, we saw that when it is a product of two numbers like what we are given here, it means before the logarithms were being added together. So that means we've got the logarithm of x, which is equal to the logarithm of 19,4 plus the logarithm of 0,462. So this is how you're going to separate. Is it an division? Is it multiplication? Is it an exponent? You separate this way of what is on the right-hand side. So a product, you were adding the logarithms. That means you're having the log of this plus the log of this. At this stage, that is where you are going to simplify each and every part on your calculator. Depending with the degree of accuracy that you are given, this is what you are going to do already. Remember, I fixed my calculator to 3 decimal places. So that means whatever that I'm going to simplify is to 3 decimal places. So this is log 19,4 like this. And this is going to give you 1,288. So we've got 1,288 plus the logarithm of 0,462. Log 0,462 like this. So this is going to give us negative 0,335. So that's negative 0,335. So you are going to combine this. That's the logarithm of x is equal to, you combine 1,288 plus a minus 0,335. So this is what you're going to have. And as a decimal, that's 0,953. All right, so that's 0,953. So this is the idea now that you're going to do. Remember that this is a log. Log x. We do not want log x. We need x because x represents the product of these two numbers. Remember, we said let x represent the product of these two numbers. So by doing this, it means if there is a log like this, you are supposed to solve for what? You're supposed to solve for x because x is the product of these two numbers. And by solving for x, you are obtaining the product. So this is the case. If you are using a log like this, it means you are in the base of 10, like I said before. So this is in the base of 10. So how are we going to determine the value of x? That means to have the value of x, we are going to remove the logarithm to the exponents. Remember the condition, if you are given the logarithm of a in the base of b equal to c. This a is equal to b to the exponent of a c. Remember the conversion that happens between log form to the index form or the exponent form. So meaning to say to find x in this case, x is going to be equal to 10 the base to the exponent of the answer, which is 0,953. But let's say in exam, I do not know the base or what am I going to do there, like the number that I'm going to use. You are working with a logarithm. So what you do is that you check on top of your calculator, everything that you're calculating, you were using this log. You were on this log here. You were using this log. So you check what is on top of that log. On top of this log, there is a 10 to the exponent of. So that's how you remove these. You remove this by introducing that which is referred to as the anti-logarithm. The anti-logarithm is on top of that log. If you use ln, you use e to the exponent of x, which is on top there. So how do I get access of this 10? It's shift on that same log. So there that 10 is 10 to the exponent of, this is exactly what you have here, of the answer that you calculated. That is going to be 8,974. So this is going to be 8, all right, remember I said 8,974. So this is 8,974. So this is what we are going to have if you multiply these two numbers using the logarithms. But if you check before, this was it. When you multiplied, this was 19,4. Remember what we had? It was 19,4 times 0,462, which gave us 8,963. And now we are obtaining 8,974. So this will be an approximate value because of the rounding off of the values, everything that happened there. This is the cause of everything that you are seeing here. So you are going to see that we could have used the ln in place of this logarithm. So meaning to say, if we were using the ln, ln, which is the Napierian logarithms. All right, or let me just use this one. So using ln, if you're using ln, you're going to introduce as the ln. So this was going to be the ln of x is equal to, at this stage, this was going to be the ln of 19,4 times 0,462. So as you can see, it is still the same thing. A ln and a log, like I explained before, simply applies the same thing. So if you're adding the logarithms, it means you're also going to add under the ln 19,4 plus the ln of 0,462. So that's it. On this stage, you calculated the log, so you are going to do the same thing, but this time it's a ln. So on your calculator, this time, you are going to be working with the ln. So that is the ln of 19,4. The ln of 19,4, like this. This is going to be 2,965. So this is 2,965 plus the ln of 0, so this is the ln of 0,462, like that. All right, so this is going to give us minus 0,772. So this is minus 0,772. So combining these two, we have got the ln of x, which is equal to what? So we're going to add 2,965 plus this negative 0,772, like this, and this is going to give us 2,193. So this is 2,193. But now take note, as you can see, the answers are totally different. This is 0, this is. So also working with the ln, what you're supposed to know is that the ln, it's a logarithm in the base of x. This one, it means the logarithm of x in the base of e. I mean the logarithm of x in the base of e. That is the ln of x, log x base e. Log x base e is equal to 2,193. So remember how we calculated our x before? We said it is equal to the base to the exponent of the answer. So it's e to the exponent of 2,913. That's how you find your x as an antilog, or you just check on your calculator. You were using ln on your calculation. So to find the antilog of a ln, it's what is on top of that ln. On top of a ln, there is e to the exponent of x. So it's simply shift e to the exponent of the answer that you calculated before. That is going to be 8,962. So this is going to give us x is equal to 8,962. So as we can compare at the end of the day, we are going to see that the use of the Napierian logarithms, which is the logarithm in the base of e, gives us an answer which is close to the answer that we are supposed to obtain. The use of a normal logarithm in the base of 10, it gives an answer which is far away from the one that you're supposed to be obtaining. So it depends with the question that you're given. Are they asking you to use the logarithm in the base of 10? Are they asking you to use the Napierian logarithms? It's up to you. It's up to the question that you're given. But if the question is just use logs, you just use whatever that you want. Are you going to use this part? So this is what you're going to need. From the expansion that you have, the separation, these laws, these are the laws that you are going to need, each and every part. So you are supposed to expand into the simplest form, then whatever that you're going to have there, you simplify as much as you can. So whether there's an exponent, whatever that you're given, this part, you are going to use the law. So if you check number 2 is same, you're just going to try that one. So the advantage of these ones, you simplify first. 32 to the exponent, you get an answer. Then you work with your logarithms. If your answer is far away from the answer from the exact answer, then it means it's wrong. Try again. So I want you to try as many questions as you can, but I'm just going to give you typical exam questions, how they can be like what you're given on number 13. If you check number 13 there, I'm not going to do all these questions. Try as many questions as you can. Number 13 is a typical exam question that you can be given, which is 3,8 to the exponent of 4 divided by 0,943. So I'm going to use log, use whatever that I want. You choose what is best to you. So in this case, I'm going to use the lean, which is the Napierian logarithms. We are dividing here. So this simplification that we are seeing here is same as it is written as 3,8 to the exponent of 4 over 0,943. It's a division. That's a division. So we can let x2 be equal to this. By letting x, we can introduce the logarithms both sides. So introduce logs in this case. So if you introduce a log, it means we are going to have the logarithm of x equal to the logarithm of what is on the right-hand side, which is 3,8 to the exponent of 4, everything over 0,943, like this. So the question is, how are we going to simplify from this case? How are we going to simplify? With the same situation, remember what I said, there is a fraction there. It's a numerator to the denominator, meaning to say this is a division. The logarithm of a over b, remember we said it was taken from the logarithm of a minus the logarithm of a b. You are subtracting, you are dividing, so it means you're subtracting the logarithm of x is equal to the logarithm of 3,8 to the exponent of 4 minus the logarithm of 0,943, which is to the denominator. But also considering that we saw that if there is an exponent from the logarithm of a to the exponent of n, we saw that this is going to give us n log of a. An exponent is multiplying the logarithm. There is an exponent of 4, so meaning to say you're going to drop this exponent to multiply the logarithm. So the logarithm of x is equal to 4, the logarithm of 3,8 minus the logarithm of 0,943, which we can simplify each logarithm as long they are single logarithms that you are remaining with, without exponents, without any fractional x, anything that is affecting the log. You can simplify this 1, 1, each on its own. All right, actually, I wanted to use a lean. Now, look, I ended up using a log. It's fine. I'm going to use a lean on another question. It's fine. All right, I've used a log. I'm seeing it now. So this is the condition. You are going to simplify each and every part. So the logarithm of x is equal to 4 log 3,8. So you are going to simplify this on your calculator, each and every part separately. You can fix your calculator to 3 decimal places as mine. So this is for the logarithm of 3,8. So this is going to give us 2,319. So 2,319 minus, all right, you are subtracting, what are we subtracting? The logarithm of, so this is the logarithm of 0,943, which is a minus also, minus 0,025. All right, so this is what you are going to have at the end. So the logarithm of x is going to be equal to what? Minus and minus, that's a plus. Or just use your calculator as usual, 2,313 like this, minus 19, sorry. 2,319 minus, what are we subtracting? We are subtracting a negative 0,025. So meaning to say our calculator can simplify this, does not mind anything. That is going to be 2,344. So here we're going to obtain 2,344 from this simplification that we are having. But remember what I said before, this is in the base of 10. So x is going to be equal to 10 to the base of the answer, which is 2,344. So this is the value of x from our calculator. We are using a log, and on top of a log, there is a 10 to the exponent. So it's shift log you have 10 to the exponent of the answer that you have, and this is going to be 220,800. So this is 220,800, which is 8. So this is the value of x, meaning to say this whole part, if you simplify, we're going to have something close to that. That is something like this. We were given something like this before, 3,8 to the exponent of f4, everything divided to 0,943. And this is going to be 221, like that. So it's like I said before, if you're using logarithms, you say logarithms, they give you an answer which is a little bit far away. But if you use the Napierian logarithms, the lean, you are going to see that your answer is going to be very, very close. I want you to try that and see what you are going to have at the end. All right, so these are the typical exam questions actually that you're going to have. Like when they are asking in exam, they are going to ask something like this, something like what you have on number 19, number 16, all these questions that you're seeing, 17, 19, you see, these are the typical exam questions. All right, let's see number 17. Number 17, let us try to apply the Napierian logarithms on number 17. We are given, that is, all right, so let us see what we are given there. So this is it. Thus, we have got the cube root of 44,4 multiplied to 4,11, everything over. So this whole part is divided to 1,09 to the exponent of a 3. So if we were to use our laws in this case, the first thing is to get rid of this cube root and so on. All right, so let x be equal to this part, and this is same as 44,4 to the exponent of 1 over 3. Remember the cube root to the exponent of 1 over 3 times 4,11. Everything over 1,09 to the exponent of a 3. So if x is representing this, we can introduce our logarithms. In this case, like I said, I'm going to introduce a ln. So I'm going to have a ln both sides. So this is the ln of the whole of this part. So what does it mean? It simply means the ln of x is equal to this, where I can use the laws. There is a division, the numerator to the denominator. So we saw that if you are dividing like this, you were subtracting the logarithms. So it was the ln of 44,4 to the exponent of 1 over 3 times 4,11 minus, you were subtracting to this one that is in the denominator, which is the ln of 1,09 to the exponent of a 3. So with this simplification that we are having, we can apply again the product. What made us to multiply these two numbers? It is because the logarithms were being added before. That is why we are multiplying these numbers. So it was the ln of 44,4 to the exponent of 1 over 3 plus the ln of 4,11, like that. Addition makes us to multiply these, minus the ln of 1,09 to the exponent of a 3. But remember also, I mentioned that if you are given an exponent, it means this exponent was multiplying a logarithm. So meaning to say this can be simplified as the ln of x is equal to, I'm going to drop this exponent here, drop this exponent here. So meaning to say this is going to be 1 over 3, the ln of 44,4 plus the ln of 4,11. So this is ln, 411 minus, drop the exponents, is going to be minus 3, the ln of 1,09. So with this, we can simplify each and every part. The ln of x is equal to what? Simplify each and every part on the right-hand side on your calculator. All right, so this is what we're going to have. Let us just save our calculator. So meaning to say, we are going to have 1 over 3, the ln of 44,4. All right, so that's 1 over 3, like this. The ln of 44,4, like this. And this is going to give us 1,264. 1,264 plus the ln of 4,11, the ln of 4,11, like this. And this is going to give us 1,413. So that's 1,413. Minus, we subtract 3 log which is 3 ln. So this is 3 ln 1,09 like this. So if we were to simplify this, this was going to give us 0,259. Okay, so simplifying everything on the right-hand side, that means the ln of x is equal to, going to add everything, 1,264 plus, okay, let's add plus 1,413 plus, all right, there's already a minus there. All right, so this is minus 0,259, something like this. And that will be 2,418. So this is 2,418. Not forgetting this is a ln. So to find the anti-log of a ln, if you are working with a ln and you want to determine the anti-logarithm of a ln. So this is anti-log, which is the reverse of what we are given as a ln. Remember, I said a ln of x means the logarithm of x in the base of e. And also on a calculator where there's a ln, there's an e to the exponent on answer. So it's shift ln, which is, we've got the e now, to the exponent of the answer that we have, which is 11,223. So that's the value of x. So to find x, you find the antilog of that. So x is equal to e to the exponent of 2,148. Which is going to be 11,223. So that's 11,223. So this is what you're going to have at the end. So like I said, you can prove that at the end, 11,223. Let's just see on our calculator what way we're going to have if we're simplifying this direct. So that was a fraction there. Then we've got the cube root of 44,4. That is 44,4. All right, times 4,11. All right, sorry for that. This is 4,11. Everything over, that's going to be 1,09 to the exponent of 3, like this. So this is going to be 24,212. 24,212. Oh, guys, this is far, far, far away. This is far, far away. All right. Is there any way that I made an error there? Let's see. All right. There's, okay. I saw, no. There's a comma there. There's a comma there. There is a comma there. So this is 11,283. 11,238. 11,238. So as you can see, if you're using the Napierian logarithms, your answer is at least close, very, very close. As you can see, 11,2 something is different from when you are using direct logarithms. Your answer is going to be a little bit shifted. But the Napierian logarithms, at the end, we can conclude that they are best to use because your answers, they are going to be exactly in the range that you are given. But that does not mean that you are not allowed to use the normal logarithms. No, you can use your normal logarithms. So I want you to try as many questions on this exercise. Where you feel like there is a question, let me know so that we can have those typical questions worked separately so that you do understand how to apply your laws of exponents or laws of logarithms wherever it is necessary. For now, that's it. Till we meet again.